Hi everybody, my name is Jordan Kalesha and this is my supply chain in-depth topic response for MIS 456 over the summer semester. And today we're going to be talking a little bit about enterprise asset management and IoT, also known as Internet of Things. And these are two very distinct topics, and they're extremely large topics to discuss in one short presentation, but I'm going to do my best to provide you guys with a good amount of information, and hopefully you'll be able to take some of it with you in your future careers. I hope you enjoy. To start, I felt it necessary to give a bit of an explanation as to what enterprise asset management is. I found a definition that was written by a consultant and EAM blogger named Tracy Smith. He conveniently describes enterprise asset management as a strategy for managing physical assets that coordinates the enterprise to maximize the total value that assets deliver over their life cycle. Although it's a simple definition, the practice of EAM can become very complex very fast. EAM software is a tool that helps enterprise organizations achieve managing assets in an efficient manner through many kinds of processes and activities. I actually encourage you to pause the video and either do a couple of cartwheels or maybe rotate your laptop 360 degrees to look at the graph on the right that, although is not comprehensive, shows many of the activities, processes, and practices that are involved in an EAM software. These activities help large firms step away from legacy systems, multiple disparate databases, time-consuming spreadsheets, non-value-added processes, and reactive decisions into more proactive, organized, and holistic approaches to managing their assets by using one single system. EAM software is further enhanced when integrated with other software like enterprise resource planning, customer relations management, or even geographical information systems. The result is greater transparency, accountability, and the opportunity for increased asset productivity and subsequent revenue growth, or even smarter spending practices. EAM practices and software can be found in a wide variety of industries as shown in the table. The important thing to note is that an EAM software can be used in any organization that has asset-intensive needs in its business operations. In other words, any organization that owns and operates tangible assets that are critical to their business, like a manufacturing company's machinery, could benefit from utilizing an EAM system. If you take a moment to think about some of these industries' use of their assets, you might find yourself becoming a little overwhelmed with how asset reliant they are in their operations and how crucial efficient asset management becomes. Since there are many EAM solution providers, I decided to focus on some of the larger existing companies. Gartner Inc. is an IT service management and research company that created an analysis tool called the Magic Quadrant. Gartner analysts research and distribute firms and organizations that produce and sell similar products into one of four quadrants. Without going into too much detail about the Magic Quadrant shown on the right, the graph lists some of the larger EAM software vendors as of 2018 and how they rank in comparison to one another. The important note is the top right quadrant, also known as the leader quadrant. It shows two vendors that both have a completeness of vision and the ability to execute their EAM software products and are at the forefront of providing their respective solutions, IBM and Infor. Fun fact, Infor has a presence in downtown St. Paul at the Lawson Commons building and is known as Infor Lawson. I encourage you to pause the video and see if you recognize any of these vendors. For more information about how the Magic Quadrant works, I will post links to a guide on how to read it, as well as the IBM article itself, if anyone is interested. At this point, you might be asking yourself where IoT fits into the EAM picture. Since one of our videos for this week goes into detail about IoT, I decided to focus on IoT devices and how they work in conjunction with EAM software. IoT devices are simply internet-enabled and connected objects that an enterprise can attach to assets to perform some kind of function. The graph on this slide, reading from left to right, depicts how organizations can use IoT sensors to enhance their operations. The enterprise could start by determining what kind of functions or information the sensor should or could provide. Different protocols can be used for data transmission, but for simplicity's sake, let's use Wi-Fi and cellular services as our method. Then, the type of sensor, of which there are many, can take measurements for monitoring and alert purposes, or even perform activities that control the asset or an asset's component in some way. This information is then fed back into the EAM software, where useful information can be derived and better, or even automated decisions can be made in terms of that asset. To further illustrate the example, let's say that we are a wind turbine company that generates wind electricity and sells it to a utility provider. The turbine on the top left of the graph shown will be one of our wind turbines that contains a generator that we have installed an IoT vibration sensor on. The sensor has detected a vibration that falls outside of our calibrated acceptable thresholds and sends an alert to our EAM software via the internet. The EAM system then automatically creates an inspection work order and assigns it to the appropriate technician to go and investigate. The technician can access information about the generator using their mobile device QR scanner that is connected to the EAM software. Historical data can populate the technician's mobile device, showing all past work order history or any other pertinent information like how to perform the inspection itself. In the end, other EAM users, like upper management, can access information about the problematic wind turbine and generator as well. Using the many features of the EAM tool, they could answer questions like, how frequently is this generator having problems? How is it performing in comparison to other generators? How much did it cost? How much is it costing to fix? Or even, is it time to replace the generator? These are just a few of the examples of how an EAM system could function for an enterprise. There are both realized benefits and challenges when investigating EAM software and the use of IoT-enabled sensors. In terms of EAM software, if implemented appropriately and successfully, it can generate both a return on the investment of the software itself, as well as generating a greater return on an organization's assets through more efficient maintenance and use practices. Greater transparency is also achieved by having a single source of truth to track assets, costs, parts inventories, maintenance, as well as disposal activities. In doing so, full lifecycle asset analysis can occur. EAM increases accountability by maintaining historical information, maintenance audit trails, and by having the ability to enforce regulated asset management practices when required. EAM software can also help make asset management more efficient by moving from reactive to proactive maintenance and practices. For example, using trend analysis, preventative as well as predictive IoT maintenance methods, organizations can maintain and fix assets before they break down rather than after they break down, potentially saving large amounts of money and keeping the asset up and running. All of these practices and features can help organizations and the people within them to make better decisions like when to requisition, commission, reconfigure, and even decommission assets. EAM software comes with some substantial challenges, however. They can be very complex systems that are difficult to implement, usually involving big time commitments and large investments. For example, imagine implementing an EAM software for a global organization that has disparate and questionable data relating to its current assets, of which all has to be compiled in one system. In terms of IoT, the benefits of deploying IoT sensors within an enterprise include having real or near real-time data transmission that can carry useful information and allow key insights into overall asset performance. IoT sensors in conjunction with an EAM software can facilitate automated workflows and cut out non-value added processes, paperwork, and form completion. Again, with these insights, better decisions can be made when IoT devices are used in tandem with EAM. Just like with EAM, however, IoT sensors can be challenging as well. For example, the calibration and installation of them can be labor-intensive and potentially difficult to set up. This is obviously governed by the complexity of the sensors as well as the assets, but the point still stands. Security is also a very large issue in terms of IoT sensors. I'll post an article that I found that discusses some large data breaches that have occurred because of a lack of IoT security and the easy access gained into an organization's IT infrastructure as a result. Lastly, there is something to be said about overdependency on technology. At the end of the day, it is the human capital that is needed to make sure that all the processes and activities within an organization are working as they should. After reading some of the material for this week, you might be asking yourself what the difference between an EAM software and a computerized maintenance management system is. The answer is that they are different, however, it is generally seen as EAM being born out of CMMSs due to a need for more holistic features. With that being said, EAM software encompasses the features that a CMMS offers. The graph on the right is an example of some of the features that an EAM software is capable of that either does or does not overlap with a CMMS. If you want, pause the video and look over some of the points, but keep in mind that this is not a comprehensive list, nor should it be taken at face value as some CMMS vendors offer EAM-like capabilities and vice versa. The important note to mention here, though, is that EAM software focuses on the entire lifecycle of an asset, all the way from acquisition to decommission, whereas a CMMS focuses on maintenance, increasing uptime, and reducing downtime of assets. All right, these are my questions for my supply chain topic. I'm not going to go ahead and read through these to save on some time. I thought this would be a little bit of a fun way to get people engaged, and I hope you guys enjoy. Here are my references. They will all be in my response, and thank you guys very much. I hope you enjoyed my presentation.